This comes out of section 5.3, concavity and points of inflection. So in this first example here, we're asked to determine where y equals x cubed minus 3x squared plus 4x minus 1 is concave up and down, find its points of inflection, and just from that information to sketch it. Now in reality, we probably would do the previous work that we've looked at, finding intercepts, finding increasing, decreasing values, finding max, min, and we get a better sketch out of this. But because this is a relatively simple function, we might even have some idea what it looks like anyway, being that it's a cubic polynomial. But with these points of inflection and concavity, we actually get a pretty good picture. So first job I have, take the derivative. First derivative, now second derivative, the first derivative, by the way, if we did look at it closer, doesn't have any critical numbers. What you find is that first derivative is never zero, and so it actually turns out that function is basically always increasing. But that aside, that's just a side note here. Looking at the second derivative, there's only one value of particular interest, and that is what's going on at x equals 1. So take a look at x equals 1, and to the left of it, to the right of it, if I put in a number below 1, the second derivative is negative. If I put a number greater than 1, the second derivative is positive. So what we have here is concave down on the interval everywhere from negative infinity to 1, and then concave up on the interval from 1 to infinity. So given that the concavity does change at x equals 1, we have a point of inflection. So our point of inflection is at 1 comma something. Now I have to put the 1 into the original function to say, what does that equal? So 1 minus 3 is negative 2, plus 4 is 2, minus 1 is 1, and we have a point at 1 comma 1 that is a point of inflection. So to sketch that, that's not a lot of information, but what we would find is that at 1, 1, we have a point. Everywhere to the left of it, we have concave down, and everywhere to the right of it, we have concave up. I put in this 1 point here at negative 1 just because quick glance at the function above, I can see that the y-intercept is negative 1, but we have a function basically that has that kind of curve downward to there, and then an upward curvature to it on that side. And so, if you had a graphing calculator, you could confirm to yourself that that's true, but that's concavity and points of inflection being used to draw a picture.